So 17.6 times the cosine of 45 degrees. And I'm going to put the units in at the end, intermediate steps. I don't have to, but yes, thank you. It is indeed newtons. So now I've got my two I-hat components here, and doing the fancy math, 8.65. And if I don't specify on test and quiz, on tests I generally don't. There is. That's possible I've made a careless error in there. So when you rewrite your notes, double check. Questions? By the way, while people are writing stuff down, on the pre-course assessment, out of all the years I've done it, the average is 7.49 out of 30, and this group had 8.11 average out of 30. The median was 8 out of 30, median for all the classes over the years is 7, so you can treat that as statistically the same, or that you are better than the average group. The low to high 4 was the lowest and 14 was the highest for this group, and then over all the years the lowest was 2 and the largest was 20. So interpret that how you wish. Yes, Eric.
Can you tell me where you got 8.65 from?
8.6. I added the like terms in my head, and so therefore possibly an error. Added those two together. And tell me if there's mistakes and you're double checking that.
No, you got it.
Okay. Is that okay? Other questions? So once again, I can read your thoughts. And you're going, hey, that's great, but could you make it slightly more difficult? Yes? All right, so we'll start with our 5 microcoulombs charge there, our -3 microcoulomb charge there, 8 centimeters in between them because we've already done that. And then I'm going to put one that is, let's say, 12 centimeters away and 4 microcoulombs. Let's make it -4 microcoulombs. You know what? Let's just go for it and make this slightly more complicated. I'm going to change this last one. Yeah, we could do the intermediate step that I was going to do, but let's just jump to it. This is a vector addition problem mixed with the electric forces. If this were physics 151, those microcoulombs would become some mass, and I'd ask you for the gravitational force. But we're more sophisticated, the electric force. I want to know the force on, let's just say, the 5 microcoulomb charge. So, no. Let's find the force on the -4 microcoulomb charge. I'm going to call this Q1, Q2, Q3. Force, electric force on 3. Which of course would be the electric force on 3 from 1 plus the electric force on 3 from 2. Dust off some cobwebs. We'll get this. And inside, we will dance a jig of joy. Inside, jig of happiness. Put it on. They'll dance on the inside. All right, so we have to do it separately. We have to figure that out, then we have to figure that out, and then we have to add them. So first off, the force on this -4 microcoulomb charge from the 5 microcoulomb charge is going to be in which direction?
Towards the Q3.
Towards the what?
It's going towards Q, this way.
Oh, toward this way. So they're going to repel each other.
No,
They're attracted.
Yeah, they are attracted to each other, so that will be pulled this way. What about between those two? Which way will the force be?
Repel.
Okay. Which one is going to be a bigger magnitude of force?
Probably the 5.
Yeah, this force, I mean, this charge is the same. Remember that the electric force depends upon both charges. That's a bigger charge. Well, actually, it is a little bit farther away, so I don't know right now. If it were equidistance, the 5 would have a bigger impact. However, it is farther away, so that's going to lessen it. Let's find out. All right, so first off, I need to figure out the magnitude of this charge, or of that force. Because I'm finding the magnitude, the negative sign doesn't. The negative sign is there to help us figure out direction. We intellectually know what the direction is. So 9 times 10 to the 9th times 5 times 10 to the -6th. This is 1 and 3, and 4 times 10 to the -6th divided by that distance. So I need to figure out that distance right there in green. I know that this distance is 12 centimeters or 0.12 meters. This distance right here would be
6.
And so therefore my hypotenuse will be 0.134. Is that what you said? Squared. And then someone be kind enough to crank that out on a calculator. Say it again.
10.01 newtons.
Anyone else get the same thing?
It's close, 10.02.
I used the 8.99 times 10 to the 9.
Okay.
Sorry.
You're too good for 9 times 10 to the 9? Is that the one
The
here?
notes from the video that I have
Okay.
in here, yeah.
And that's fine. On a quiz or test, I would not notice the difference. On lab, where I'm much pickier about the numbers, I might notice. All right, So we had 2 people with that answer or close enough. But I need to figure out the direction. I mean, this is just the magnitude. In order to add the vectors, I need to have some sort of direction. So let's go ahead and establish, let's go with the Luis convention. Lord, you're giving a strange look there.
It's fine.
Okay. So I need to figure this out. We'll do it correctly, and then I'll talk about the pitfalls and the mistakes that I've seen in the past that make me cringe. All right. So it's in that direction. I need to figure out, in essence, I need to figure out that angle right there. How do I figure out this angle? And I'll cleverly label it theta. This is 6, 12, theta. That is a right angle. How do I find theta? Okay.
Tangent.
All right. So I know the tangent of theta would be opposite over the adjacent, and so theta would be the arctangent of 6/12. Or for reduction bands, the arctan of 0.5. And that is 26.6
Yes.
degrees. All right. So I know the magnitude, I know the direction. This is the angle based upon the vertical. We need to break it up into its components. So this is 10.01 or 02, and that's a 26.6 degree angle. And so this will be 10.01 times the cosine of 26.6 degrees, and this will be 10.01 times the sine of 26.6 degrees. Then you pull out your slide rule, your abacus, your table of trig functions, or your calculator.
Cosine 26.6 is 8.95, and 10.01 sine 26.6 is 4.48.
All right.
Newton, sorry.
I wanted to save that up, because there's something I forgot to do over here. So 26, so I know that the force, the electric force on 3 from 1 is, it's going to the left and up, negative 4.48 newtons I hat plus 8.95 newtons J hat. We've done almost half the problem. Rinse and repeat. Now, we could have done this without actually using the trig functions on the calculator. We already found what the hypotenuse was. The hypotenuse is 30. Thanks. I feel like I hadn't done that in a while. This is 13.4 centimeters. That's where this comes from. I know that the cosine is the adjacent over the hypotenuse, and so instead of figuring out the angle and figuring out what the cosine of that is, I could have just done 10.01 times 12 over 13.4. And up here, this would be 10.01 times 6 over 13.4. It depends upon whether trig brings you joy or not. All right, so now we have to figure out the other one. It's the similar process. It is not, I can't say that doing problems like this, the answer is really not a thrill. You know, I know most of physics, it's just one emotional high after another. This one does not bring me joy. However, it is something that you really should know how to do. All right. So I now need to do the other one. So I had a -3 microcoulomb charge here, I believe. I know that's 2 centimeters. I know that's 12 centimeters. And that's -4 microcoulombs there. Okay. I need to find the magnitude first. It's gonna be 12.8. Wait for the magic review. Drop back for just a second. That was 212. Well, actually, square root of 148 probably works. All right, so. What'd you get?
For that, 12.17 for that, if you round it.
All right. So the magnitude of the force, electric force on 3 from 2, the magnitude 8.99 or 9 times 10 to the 9th times -3 times 10, I'm just looking at the magnitude, 3 times 10 to the -6th times 4 times 10 to the -6th divided by 0.0148. This would be 12.17 squared. If you did not round it, did not make a Carol's error.
Why is it 0.0148 and not 0.148? Where am I? I'm missing something.
If you put this into meters and did 0.1217 squared. Okay.
Thank you.
And what do we get as the magnitude?
Point
0.729?
Do we need to square the bottom?
Yeah, we squared.
That is squared already.
Already? Oh.
Oh, wait, never mind. No. Don't leave that wrong. I forgot the number.
7.29. All right. Anyone else get the same thing?
Yeah.
All right. So I need to break it up. I need to figure out the I hat, J hat components. So I know for my triangle here, this is 12, this is 2, this is the square root of 148. I have the arrow pointing that direction, but it's a repulsive force, so it's going that way. So it's going to be in the I hat direction. I know it's to the left, so it's going to be negative. And then it'll be 7.29 times the, I guess we're doing the opposite here, so 2 over the square root of 148. And then negative j hat, because it's going down, negative j hat, 7.29 times 12 over the square root of 148. I thought through the directions. I know that it's repulsive and it's going in, basically pointing to the third quadrant. And so I'm not worried about signs inside here because I know it's going to be negative I hat, negative j hat. Slightly different than we did it the first time, the previous one where we actually found the angle. This time I'm skipping that step.
Shouldn't the numbers be like 0.02?
I have this as 148, so I would need to change that to 0.0148 and 0.02 if I did that. But the ratio should be the same.
Okay.
The advantage of this method is there's slightly less rounding. Someone's going to reveal an answer that will make all our